A very special good afternoon to all my lovely children. Welcome to Tripura Interactive Virtual Class. I hope you all are good, fit and fine and came with full of energy as today's maths class also going to be very special like always. So without any delay, let's start our today's class. So my lovely children, do you remember what we have done in our last class? Yes, very good. We were doing quadrilaterals. We saw so many different kinds of quadrilaterals, right? We started with rectangle, then square, then rhombus, then parallelogram, trapezium. We saw different types of quadrilaterals and we saw their properties also. Now today let's extend our that topic. Let's see some more things. So here we are going to see today how to find the unknown quantities, that means the side or angles of the following quadrilateral. So let's see the shape of the quadrilateral. Can you tell me the name of this shape? Yes, you are absolutely right. This is called a parallelogram. So in this parallelogram, I think all of you can see exactly three missing things. Missing angles are A, B and C, you can see, right? So we have to find the value of angle A, B and angle C. And it is given, one angle value is given. In a quadrilateral, we all know how many angles are there, total 4 angles. So out of these 4, one angle is given and the shape is given as parallelogram. Why? Because you can see with two arrow sides, we can see that these two are parallel and single arrow side, that means what? Opposite sides are parallel again. So this is a parallelogram and in this parallelogram, one angle is given which is 105 degree given and you have to find with the help of these logics, that means what? First of all, the shape is one parallelogram and second of all, one angle is given already. One angle is 105. So with the help of one angle and also the properties of parallelogram, we have to find this missing A, B and C values. So can you find, my dear children? Can you do? Let's see. In a parallelogram, what we know? Opposite angles are equal. Already we know from our previous class. For a parallelogram, what we know? The opposite angles are equal. So as the opposite angles are equal, I think by observation only, one angle value to you can tell right now only. Can you tell which angle will be directly equal to 105? Taking the help of this sentence, this statement. In a parallelogram, opposite angles are equal. With the help of this statement, which angle value will be directly 105? Can you tell? Yes, very good. Angle V value will be directly 105, right? Yes. So, now to find A and C. Next, so similarly, A and C will be equal because these two are the opposite angles. These two are the opposite angles. That means according to the parallelogram law, A and C will be again equal. Okay, this one property. One more property is there. I hope all of you remember. In a parallelogram, adjacent angles are supplementary. Do you remember this? The adjacent angles are always supplementary. Means if you add the adjacent angles, the value will be how much? It would be 180 degree. Okay, so now we are having 105 and another angle is A given. That means as these two are adjacent. Why adjacent? Because here you see these are two parallel lines and it is bounded with one transversal line. So these angles are called angle A and this 105. These two are adjacent angles. So this adjacent angle sum is equal to 180 degree. So from here what we can do, you see. So A will be equal to what? 180 minus 105. If you change the side or if you subtract 105 from both sides, so what you are getting? A will be how much? A is 75. Okay, so A we got 75. Again you can apply the parallelogram rule. What is that one? What is the property? As A is 75, that means what? That means C is also 75 because C is equal to A, opposite. angles are equal in a parallelogram, we know. So that means angle C is also 75. So see how easily and so fast we calculated all the angle values, right? Okay. So here are the angle values. So here are all the 4 angle values. Now here is one question time. Let's see if you are able to answer. Okay, this is very beautiful question. How much you are able to answer by the concept? What are the concepts? Again, the reminder. First one is opposite are equal, and second one is the adjacent angle sum is 180 degree. Okay. So with this logic, you have to find the value of a plus 2b. So you have to find the value of a plus 2b. So let's see how many of you are able to answer. I am giving you time. I am increasing the time actually. So all of you try to answer this question within 45 seconds. So I gave you time 45 seconds. All of you try to answer. Your options are 303 degree, 297 degree, 279 degree, 313 degree. All of you try to answer. Can you find the answer? I think one already you will get. You can take the help of adjacent angle sum. By that you will get B. So if you get B, A will be equal to B, and then you put here to get the correct answer. Okay, your time is up. I am showing you the result. Option A is the correct option. So how will you calculate? Here you see what we know as B and 79 degree are adjacent angles. So what we can do? B plus 79 will be equal to 108, 180 degree supplementary angles. So B value you can find out from here. 180 minus 79. So after getting B, whatever the value of B, A will be also same. Now you put in this equation A plus 2B. So all of you will get the answer as 303 degree. Okay. Now I think you can guess the shape of this quadrilateral also. Can you tell me the name of this shape? Yes, very good. This is one square. In a square, all sides are equal, we know. Yes. Are squares the only quadrilaterals that have equal side lengths? What do you think? Are this quadrilateral only having equal sides? Means only for square, is it true? Or we can find some more shapes which will have equal number of sides. Means, sorry, the is there shape also rather than a square? Here you see, if you little bit compress this one, this shape, so what you are getting? This quadrilateral, you see all sides equal, right? But you see the angles are not 90 degree. Is it 90 degree now? No. Is it 90 degree now? No. Is it 90 degree? Answer is still no. Is it 90 degree? No. But you see the sides are same till now. So all sides are measurement same. All sides having same measurement. So, but this is not this is not a square. So what is the name of this shape? This is called rhombus. I hope it is clear. Now parallelogram. This is one parallelogram. Opposite sides, but adjacent. Opposite sides will be equal. Opposite sides are equal. Suppose this is 5 centimeters. So if TA is 5 centimeters, so CH will be also 5 centimeter only. Suppose TC is 3 centimeters, so H also 3 centimeter. So if it is 5, then opposite side, this one is also 5. If it is 3, then opposite side, this one also 3. But if it is 5 and all the sides are 5, 5, 5, then also it is a parallelogram only. But it is not true. It is not necessary actually. But main condition is opposite sides should be equal. So in parallelogram, opposite sides are equal, but adjacent sides may be or may not be equal. But opposite sides must be equal always. Okay. Here you see, if we measure with the scale, here you can see how much it is. one is, you can see, one is more than 5, another one is more than 6, right? Okay, what if adjacent sides are made equal in a parallelogram? What will happen, they are asking. Suppose it is equal. The length was how much? The length was 5. So again we took 5. Now here also, upper one also, if you take 5 only, TC was 5 and ATA was more than 6. So they are telling what will happen if adjacent sides will be also equal in the parallelogram. So we are experimenting this. So here you see the measurement of TC was 5. So what we did with the scale, same measurement, we cut 5 from here, 5 unit from here up to this much, and upper portion also 5 unit from here to here. So what will happen in this case? Now you see you got one shape. Now you give it name AH, your new shape, and join this one. So which shape you are getting actually? This will be a rhombus, right? So that means from here one conclusion we can get, this rhombus is also a special type of parallelogram, right? So rhombus is also coming under parallelogram, but all the parallelogram are not rhombus. Why? Because parallelogram's basic condition is opposite sides should be equal. Adjacent sides may or may not be equal. So in the case where adjacent sides are not equal, that time to it is not a rhombus. And when adjacent sides are also equal, that means all four sides are equal, and which is fulfilling the condition for rhombus, so it will be a rhombus. So okay, so from here we got quadrilateral with equal side length. Here you see this is called a rhombus. Okay. Now another question time. Let's see how many of you are able to answer this question. Question is, which of the following quadrilaterals has all four sides of equal lengths? Very easy question. Your options are rhombus, square, parallelogram, both A and B. So I am giving you time for 30 seconds because this is very much easier. So let's see how many of you are able to answer this question. All of you think carefully and give the answer. Which of the following quadrilaterals has all four sides are equal length? Which one you are thinking the more appropriate answer? You give your answer. Your time is almost up. Okay, your time up. I am showing you the result. Very good. Option D is the correct option. Why? Because rhombus also we know all four sides are equal, but no angle is 90. Similarly, square also we know opposite sides are equal and all the angles are 90 degree. So that means both rhombus and square both are having equal four sides. Option D is the correct option. Okay, now let's focus on the diagonal of a rhombus. Since rhombus is special parallelogram, it satisfies all properties of a parallelogram. So why rhombus will satisfy all the properties of parallelogram? Because this is also a parallelogram actually. This is a special type of parallelogram where all the four sides are equal. So that means rhombus is, what are the properties for parallelogram? Opposite sides are parallel. Okay, so that means for rhombus also opposite sides will be parallel to each other. So here you can see with yellow single row we can GE parallel to AM. Similarly with red color two rows we can tell EM parallel to GA. Yes. Opposite angles are equal also. Opposite angles are equal. A is equal to E equal to M. Because in parallelogram opposite angles are equal. Opposite. Okay, so we got this one. Angles 80 degrees. So here you see angle E plus angle G. Adjacent angles. So it will be how much? 180. Or if you add angle G, again in the angle A and again Again, if you add A and M, this is 180 degree, because in parallelogram adjacent angle sum is 180. So it would be true for. Again, if you add angle M plus angle E, in that case also what? Supplementary angle again they will make, that means 180. So that means G plus 80 degree. These two are adjacent angles. Similarly, angle A plus angle M, this is also 180. Okay, angle E plus angle G, this is also 180 degree. Now here you see diagonals bisect each other. This is another property for parallel. What we bisect each other. Similarly for rhombus also, as it is also special type of parallelogram. So here also diagonals bisect each other. Okay, we can prove it also. How we can prove? By taking the help of congruent triangle property, we can prove that the triangles are congruent. That means by CPCT we can tell that corresponding also equal. But here if you don't want to prove, only if you want to check, that time also you can check. How you can check? You can take one pencil compass and you can measure that one, measure the lengths. You see, one is measuring the length of G. What about EO? It is equal to what? It is equal to and G is the midpoint. That means both are intersecting. That means bisecting each other. Okay. So what makes it special with respect to diagonals? So what is making? Let us consider a rhombus. Okay. Construct that are not, they are asking you to draw two sides of same length which are not perpendicular to each other. Okay, so let's make 5. Okay, 5 centimeter we took. Next, with a protractor, you see, not not going to make it, we are making it rhombus. Also of rhombus, square having, but square having 90 degree all sides or all angles. So this is the difference between rhombus and a square. So here we are not making that special type of rhombus which is called square. So as we are making the general one general rhombus, that's why what we are doing, we are taking it not 90 degree, we are taking it something less than that, that means which is 70 degree. So 70 degree we cut, and here after joining what we will do, we will cut the 5 centimeter from there. Okay, now here you see, whatever the length of AB, that much length from A we cut one arc with the help of a pencil compass and name it as. So also how much centimeter? Whatever the length of AB, you put the needle head in the A and your pencil head at B and take the measurement and cut the length on that side of 70 degree angle which one making. So there wherever they intersect, you give the name it as D, and that means what? AD is how much? AD is 5 centimeter. So AB and AD are of same lengths. AD having 5, AB also having 5 centimeter. Okay. Mark a point C whose distance from B and D is equal to AB. Now they are are asking you to mark a point C whose distance from B and from D is AB. That means 5. So here you see you have to put the needle head on B and then you have to cut one arc. Similarly, you have to put your needle head on D and you take the AB measurement which is 5 centimeter. From D again cut another which intersect your previous arc at that point as. Now what you join DC and so let's join join. So if we join both, after that all the sides. Okay, so one rhombus. This is the construction of it. Now check the diagonals. Now you join the diagonals. That means diagonal. If we join the diagonals, you see diagonals bisect perpendicularly. So if you put your protector here at the point of intersection, what will happen? You will notice one beautiful thing. You notice, you will see that the diagonals are perpendicular to each other. It will come exactly. Conclusion we can get the rhombus diagonals bisect each other perpendicularly. First we bisecting. Now we got what is that? So that bisecting each other at 90 degree. Okay, let's prove it logically. This one though by seeing, by using protector we saw that yes, diagonals are bisecting each other at 90 degree. But now let's prove it more logically. So how you can prove that one? Suppose in exam they are asking you that you have to prove, you have to show that diagonals are bisecting each other at 90 degree. So by protector, so you can't show at that time, right, in exam paper. So how we can prove, how we can show this one logic? Okay, so diagonals of a rhombus perpendicularly, that one we are going to show now. First of all, you draw one rhombus and then you join. Okay. After that, you give the meeting point as name O. Now you consider two triangles. In your diagram, you gave the rhombus name as EG and midpoint as O. So here two triangles they are asking you to consider. What are the triangles? One is GOE. This one is GOE. Another one is MOE. This one is MOE. So these two adjacent triangles they are asking you to take. So these two are what? These two are the adjacent triangles. Okay. So after taking the adjacent triangles, we are going to perpendicular. OE is perpendicular. So that OE is perpendicular or perpendicular on GM. Why? Because AE is the extension of EO, right? EA is the extension of EO. If we extend the EO line segment, that means it will come at A. So if EO is perpendicular on GM, EA also perpendicular on GM because EO and EA representing the same strength. From here, we are going to show that EO is perpendicular on GM. First, when you consider adjacent triangle, here you can see G is equals to EM. Why can you tell? Of the quadrilateral is a rhombus, and we know that all the four sides of a rhombus are equal in length. That means GE is equal to EM. Yes. Now here you see if we took GEO it bisects, that one we know, that the property of a parallelogram as well as the property of a rhombus. That means angle will be equal to OEM. We can EO. EO is equals to EO. Why? Because it is common side for both the adjacent triangles. So the common side for both the adjacent triangle will be equal. Okay, so OE is equal because this is common. So now as we got our three conditions, that means by SAS, side angle side property, what we can tell? Triangle GOE is congruent to triangle MOE. This one we can tell. Okay, now by CPCT, what you can tell? Angle GOE is equals to angle MOE. GOE is this one and MOE is this one. Both are equal. Okay. Also by CPCT only we can tell GO is equals to OM. That means O is the midpoint of GM line segment. That means EO bisecting GM. Okay. Okay. Now next, the diagonal EA bisects the diagonal GM. From here, which conclusion we got? We got the conclusion as GO equals to OM. From here, which conclusion we got? Diagonal EA bisects the diagonal GM. This conclusion we got. Okay. Similarly, we can prove that the diagonal GM bisects the diagonal AE. How you can do? If you take these two adjacent triangles, suppose this time, triangle EOM and triangle MOA. If you take these two adjacent triangle, you can easily show that by CPCT, if you can show that both the triangles are congruent, then by CPCT you can tell EO is equals to OA. That means again O is the midpoint of AE. That means GM bisecting EA. That one we can tell. Okay. So diagonals of a rhombus bisect perpendicularly. So how we can tell diagonals bisecting perpendicularly? That one how we can show? Here you see these two angles came by CPCT equal. Now again you see this GM line. This GM is a straight line. So that means this angle EOG and angle EOM. If you add both the angle, it will form a linear pair. Why? Because GM is a straight line. So as GM is a straight line, if you add both, you will get equal to 180 degree. And just now we show that these two angles are equal by CPCT. So that means twice of same angle we can write. EOG equals to 180 degree. So that means angle EOG is 180 divided by 2, which is equals to 90 degree. So here you see these angles are 90 degree. That means the diagonals bisecting each other at 90 degree. That means diagonals are bisecting each other perpendicularly, we can tell. Okay, now let's see the construction of a rhombus. Here you see diagonals bisect angle formed by the side of the rhombus. That one you know. Okay, here you see the angle is 70 degree. So as it is bisecting, you can see clearly that this diagonal AC It is bisecting the angle DAB. How you can see only this side angle, angle CAB. How much is this? This is 35. That means this angle is 35. As full was 70, so 70 minus 35 is again 35. So angle CAD, this is also 35 degree. So that means what? AC diagonal bisecting the angle DAB. Yes. Okay. So if you place the protector, you can easily check this one. Now you can check for another corner also. You place your protector at C and experiment the same thing again. Again you will get the same result. You see 35 degree you are getting, and this side angle also 35 degree only you are getting. That means what? That means we can conclude that diagonals bisect the angle formed, right? Okay. Now properties of a rhombus. Let's see. All the sides are equal to each other. This is the first property for a rhombus. This must be fulfilled, otherwise it will not be a rhombus. Opposite sides are parallel to each other. This is also true. Opposite sides will be parallel to each other. Third number is the adjacent angles add up to 180 degree and the opposite angles are equal. Yes, this is true for parallelogram also. These two are true for, fully true for parallelogram also. So as rhombus is also a special type of parallelogram, so it is true for rhombus also. Yes. The diagonals bisect the angle formed by the sides of the rhombus. This one just now we saw. The diagonals bisect each other and intersect at an angle of 90 degree. Just now we proved, right? Taking the two adjacent triangles by CPCT, we saw that the linear pair, in the linear pair, both the angles are equal actually by CPCT. So we took the same angle. That means the angle value 5 degree. We just, that means the diagonal bisect each other and intersect 90 degree. We can tell. Yes. Here is one question time for you all. Let's see how many of you are able to answer this question. Your question is, which of the following options is or are true? You have to tell maybe more than one is true or maybe one sentence is true. So you have to tell which one is true. Your options are all rectangles are square. You have to think. All parallelograms are rhombus. Some rhombus are not square. None of the above. So this is the question. All of you think logically and give the answer. Try to give the answer. I gave you 30 seconds time. So all of you try to answer this question. Think logically. Are all rectangles are square? You imagine kind of rectangle figure in your mind and think whether this is a square or not. If your answer is no, that means option A not correct. Similarly, you think about option B. All parallelograms are rhombus. You think about any parallelogram, any normal parallelogram which having opposite sides are equal but adjacent sides are not equal. Are they rhombus? Of course not. For a rhombus, what we know, all sides should be equal. And C number option you see, some rhombus are not square. Is this true? Yes, this is true because some rhombus which are having the side angles are not equal to 90 degree. These are not square. That means option C is correct option. So your answer is supposed to be option C. Now this is the shape of a rectangle, right? And if you compress the side, that means if you make the length and the breadth equal in measure, that time what is the name of the new shape formed? Can you tell the name? Yes, this is called a square. So this is a rectangle and this is a square. Square is a special rectangle with each of its sides equal. So from here you can tell This square is a special type of rectangle. That means what? That means all squares are rectangle. But all rectangles are not square. Why? Suppose here one rectangle given in your first diagram you see, you can clearly see that opposite sides are equal but adjacent sides are equal, right? Here the length, if length is suppose 5 unit or 5 centimeter, you can tell that breadth is 4 centimeter. You can see clearly. You can see clearly that breadth is little bit smaller than the length. So if it is 4, this side is also 4 centimeter, 5 centimeters, opposite side, this is also 5 centimeter. And this is what, this is a rectangle. But in a square, all sides you see 4, 4 and 4. But it is fulfilling the condition that opposite sides are parallel and equal. And each angle is 90 degree. That means it is the definition of a rectangle. This square fulfilling the definition of a rectangle, that means obviously this square is a rectangle. But this rectangle is not fulfilling the condition for a square. Why? Because all sides are not equal. You can see in the first diagram. Two sides are equal, 5, 5 centimeter. Two sides are not equal. Another pair of equal sides which are 4, 4. That means two pair of equal sides we are getting, but for a square what we know, all sides should be equal. So as here we got only opposite sides equal, adjacent sides not equal, that means this is a normal rectangle, right? So that means it is your first diagram, no, it is not a square. But in the next diagram, this is fulfilling the condition for square also, this is fulfilling the condition for rectangle also. So I hope this much is clear. Okay, so we are going to continue from here only in our next class. So today we are concluding ourselves this much only, and I will meet you in the next class. All of you prepare well at home. Okay, bye and take care of yourself. Thank you.